Hey everybody, it's Miss Moran, and I'm back to talk this week about lines and line segments and polygons and figures and all things geometry. And we started this week with a review of some things that we did before angles, knowing the difference between lines, line segments, and rays. I'm going to go pretty quickly through these things, and I'm just basically reviewing some vocabulary. So a line connects 2 points in a straight path, which continues forever in both directions. The arrow showed that it shows continuing to the left and to the right. This is an abbreviation for the phrase line AB. We use this symbol above it to show that that is a line that continues. This is similar to a line, only it has a beginning and an end point. A starting place at C and an ending place at point D. It's in a straight path but does not continue forever. We read this line segment CD. It can also be read line segment DC backwards. This is a ray. A ray is a combination of both line segment and line. It has an end point but continues through another point into the other direction. This arrow here is a symbol that says ray EF. Then we talked about what happens when lines interact with one another. These would be lines that are intersecting. Intersecting lines just meet or cross. These go through one another. This is an intersecting line that just meets at a point. That point of intersection would be an additional point. Then we have parallel lines. Parallel lines are lines that are an equal distance apart. They will never run into one another, even if they continued on forever in both directions. As an abbreviation, we would say that this is line GH, and it is parallel to line IJ. This symbol means parallel. Very important that it's written vertically instead of horizontally. We don't want it to look like an equal sign. These are also parallel lines. Sometimes students are confused about the length of the line. They might think that they have to be the same length. These are not. This is a shorter one and a longer one. What makes them parallel is that they're an equal distance apart throughout. They never come closer. They never get further away from one another. The exact opposite of parallel lines are perpendicular lines. These are not only lines that do cross, but they cross in a special way. Perpendicular lines are lines that meet and form right angles. They can go through one another like this. They can meet at an intersection like that. They can form an angle like this, and they can be a little crooked, which is okay. Sometimes we say, we'll just turn our book and look at that another way. It makes it a little bit easier. As an abbreviation, we would write that this is line segment MN, and it is perpendicular to line segment KL. Okay, again, we want to make sure we don't use another symbol that looks like a plus sign for perpendicular, and we don't want to use what looks like a T. That might be confusing as a letter. So sort of like an upside down T here is the symbol for perpendicular. That way we don't have to write out line segment MN is perpendicular to line segment KL. Once we know about lines, then we learn about polygons. Polygons are going to be figures that are two-dimensional. So they're flat and they're closed and they're made up of straight line segments. Students need to know the names of all of these. Any three-sided figure is a triangle. Four-sided figure, be careful, is not just a square or a rectangle. It's known as a quadrilateral. Squares and rectangles are some examples of quadrilaterals, but any four-sided figure we're going to call a quadrilateral. Five-sided figure is a pentagon, 6 is a hexagon, and 8 is an octagon. Among these triangles, we want students to understand that a triangle is not just a triangle. They don't all look like this. These are also versions of triangles. These have some special names, and we'll talk about those in a second. But any three-sided figure would be a triangle. These are some examples of some other four-sided figures. Those are all quadrilaterals. These are pentagons. These are five-sided figure. This is a concave pentagon. Looks like one of those sides is kind of caving in or been pushed in, but still 5 sides. And a hexagon, a 6-sided figure. We focus quite a bit on triangles, in that triangles can be named and categorized a couple different ways based on either their angles or their sides. This was a review of what we did last unit with angles. So anytime you have an angle, a triangle that has 1, 2, 3 acute angles, all 3 acute angles, it is going to be an acute triangle. If it has 1 right angle, it's going to be a right triangle, and it's always going to have acute angles as well, otherwise it wouldn't close. But it's not about the number of them that there are, just as long as it has a right angle is a right triangle. And this angle right here is an obtuse angle, so that makes it an obtuse triangle. Also has acute angles. We're going to name it for that 1 angle. So 3 angles, all 3 angles acute is an acute triangle. any right angle in a triangle is a right triangle, and any obtuse angle in a triangle is an obtuse triangle. Now, additionally, triangles can be named for their sides.
What position does that mean?
So equilateral triangles are going to have 3 equal length sides, or what we call congruent sides.
So it's not a teacher?
We use a symbol here to show that this is one length, this is going to be the same length, and this is also going to be the same length. That way we don't have to get out a ruler every time and measure to make sure it's exactly the same. If we see that mark and it's the same mark on each side, then we're going to say that those are all equal lengths. An isosceles triangle is somewhat similar to an equilateral triangle. It has 2 sides of the same length. So this side would be 1 length. This side here is going to get 2 marks on it. That shows that that is a different length side. And this one's also going to get 2. It shows that it's a different length side from this one, but it's the same from these 2 here. So 2 sides of the same length is going to be an isosceles triangle. And then a scalene triangle is going to have 3 sides of all different length. We have a short side, part of a medium length side, and a third side that's a longer side. So 3 different marks shows these are 3 different length sides. So when I'm looking at triangles, I might look at these and say, well, these are both right triangles because they both have a right angle, which is correct. But they have different length sides. This one here has these 2 sides that are the same, and this is a different length side. So this is going to be a right triangle, but it's also going to be an isosceles triangle. See, I can't do this while I'm speaking and spelling at the same time. E-L-E-S. This is a right isosceles triangle. This one over here is going to have a different length side here than it does here, and this third side is different too. So this is going to be a right, but also a right scalene triangle. All right, these are all versions of acute triangles, but they're all different acute triangles. This has all 3 sides equal in length, so that is an acute equilateral triangle. This has 2 sides of the same length, so it's an acute isosceles triangle. And this has all 3 acute angles, but these are all 3 different length sides. This one's not quite over the midline, so this is a little bit longer side here. Okay, so these are acute equilateral triangles, acute isosceles triangles, and acute scalene triangles. So we just want students to recognize basically that triangles can be classified based on their angles, but also can be classified based on their sides. All right, and then the last thing we're going to do this week in building polygons is quadrilaterals. And quadrilaterals can be very heavy when it comes to vocabulary, and there's a lot of different exceptions where things can be categorized in more than one way, so this can be a little challenging sometime. So with quadrilaterals, that's any 4-sided figure. These would be what we call general quadrilaterals, or just any 4-sided figure. Nothing really special about their sides or angles. Some other quadrilaterals do have some defining features about their sides and their angles that makes them special, and so they get different names. One thing that happens is because so many of these figures can fit into multiple categories, students get confused about what the defining features are because they start listing some common features, but we're going to try to leave it to just defining features, and that will help us to identify what some of these things are. And we're going to start first with the parallelogram. So a parallelogram is any quadrilateral that has 2 sets of parallel sides. Okay, so here my top side is going to be parallel with the bottom, and then left side is parallel over here with the right side. Now, because this is what we think of when we see our typical parallelogram, it's okay to call that a parallelogram, but there are other things that fit into that category as well. So anything with 2 sets of parallel sides is a parallelogram, which means, I know that I'm able to draw this with one hand. A rectangle. A rhombus, and a square are also going to be examples of parallelograms. Okay, so they have the parallel lines top and bottom that are opposite from one another, and left and right. Now what gets confusing is we can say there's different things about these as well, like their side lengths and their angles. These are right angles, these are acute. None of that defines a parallelogram. Those are some features of these items, but what makes something a parallelogram is it has 2 sets of parallel sides. So we're going to stick to that for that meaning. This is our typical parallelogram we think of, but these also fit into the category of parallelogram. Okay, the rhombus. The rhombus is something that has all sides equal in length. Basically, equilateral. So all 4 of those sides are equal, which means that is not the only thing that is a rhombus. Square is also a rhombus. Now, when we see the square, we don't often call it the rhombus, but it is a rhombus. Rhombus is just something that has all sides equal in length. Okay, the rectangle. Rectangle, very mistakenly referred to as the figure with 2 long sides and 2 short sides. That is not what makes something a rectangle. That's what gets students confused. What makes something a rectangle is that it has 4 right angles. Which means if it has 4 right angles, the square is also a rectangle. Okay, 4 right angles, square is a rectangle. So we start noticing the square seems showing up in all of these. The square is a parallelogram. It has 2 sets of parallel sides. The square is a rhombus. It has all sides equal in length. The square is also a rectangle. It has 4 right angles. When we get to the square has 2 defining features. It has 4 right angles. It also has all equal length sides. So some of these other things that the square was able to be categorized cannot be categorized as a square. This is a square every single time, and it looks only like this. It can be different sizes, but none of these fit into the category of square because it has those 2 defining features. Sometimes I call the square a snob. Like square likes to be hanging out with all these other parallelograms, but then square is all by itself. Does not let anyone else into its group. So all of these here, I have this little squiggly line here. Everything above that, all of these fit into the category of parallelograms because of their 2 sets of parallel sides. The next one we're going to look at is a trapezoid. A trapezoid is a little bit different because unlike the parallelograms that have 2 sets of parallel sides, it does have parallel sides, but it only has 1 set. So it has, in this case, the top and the bottom are parallel, and this over here is parallel. And some students look at this and think, this is our typical trapezoid. It has to have acute angles and obtuse angles, but that's not true. The types of angles are not important in a trapezoid. What is important is that it has only 1 set of parallel sides. That's why both of these can be categorized as a trapezoid. All right, and then another one, and this does not fit in the category of anything related to parallel sides, is the kite. The kite has no parallel sides, and it is a figure that does have equal length sides though, but unlike the parallelograms that have the equal length sides opposite of them, the kite has its equal length sides adjacent to one another. So it has 2 of those shorter length sides there, and then it's got these 2 longer length sides here. Also, if you were to do a line from these diagonals, you would end up with a perpendicular and a right angle in the middle. This is not real important for 4th grade, but it does exist and shows up in our work sometimes, so I want students to be recognizing that a kite is a quadrilateral. It does have some special features about its sides, but none of them are parallel. Okay, so quadrilaterals that are parallelograms are going to have 2 sets of parallel sides. Trapezoid has only 1 set of parallel sides, and then the kite has no sets of parallel sides. All right, this is a big thing right here, knowing that a square can be a rectangle, but a rectangle is not a square. Anything with 4 right angles is going to be a rectangle. Anything with 2 sets of parallel sides is going to be a parallelogram. All right, lots of vocabulary and lots of different ways of naming things and categorizing things and sorting things, so it can be a little bit confusing. I appreciate your time watching, and we will be practicing this for the rest of this week, and then we'll take a break over spring break, and we will pick it back up when we come back after break. All right, thanks for watching.